Oh, look at that blueberry pie. Oh, doesn't that just make you want to learn some math? Bet you thought I was going to say eat some pie. Psych! We're going to learn some math today, and we're going to continue with this thing called scientific notation. Our goal for today is to find products and quotients of numbers expressed in scientific notation. So remember, products would be multiplication, quotients would be division. So we're going to multiply and divide scientific notation numbers. So let's do a quick review here first of some of the things we've learned with exponents and scientific notation. So exponents, first of all, this was last time. It's a number when you express it as a product of a factor and a power of 10. So a number times the power of 10. And that factor has to be between 1 and 10. Um, if you look at it this way, it would be a number times 10 to the power of something. That's what scientific notation is. When you go from scientific notation to standard notation, we first determine what the exponent is, and then we start at the decimal point. If it's a positive exponent, we move the decimal to the right that many times. If it's negative, we move it to the left, and then we add in any zeros or commas. If we're going backwards, if we want to go from standard notation to scientific notation here, I guess an actual number, and put it into scientific notation, it's all backwards. So you locate where the decimal point would be, move it until it would make a number between 1 and 10. Write it in that form. If you move the decimal to the right, in other words, if it's a big number, you gotta move it to the right. Sorry, if it was a little number and you move it to the right, it's a negative exponent. If it was a big number, that means you had to move the decimal to the left. It's going to be a positive exponent for that power of 10. And here's some examples. It says write the following write it not in scientific notation. All right, so number one, we're going to take that and we're going to take 6.4. And since it's a positive or negative 7 exponent, we're going to move it 7 to the left. 1, 2, 3, 4, 5, 6, 7. This is where the decimal is going to go, and we're going to fill in all the zeros. So this number is actually 0.000000064. That's why we write it in scientific notation, anytime there's that big of a number. Now, this is going backwards here for this one on the right. The decimal would be here, and we want to move it so it's until it gets to a number between 1 and 10. 5.6. That would be right here. So our number is going to be 5.6. And since it's a large number, it's going to be a positive exponent. And it's going to be, we moved it 1, 2, 3, 4, 5, 6, 7. Exponent of 7. That's how you put it into scientific notation. So today we want to first do multiplication with scientific notation. So I'm going to give you some steps. You can write them down and then follow along with the examples, because that might benefit you here, just to look back at these steps. So the first step would be rewrite the problems with parentheses. I'll show you what that means in a sec. They're probably already going to be in parentheses, just so you know. Second one, multiply. We'll put this right here. If not already in parentheses. Multiply the constants together. So that's that number out in front, the factor, the number out in front. We're going to first multiply those two together. Then we're going to multiply the powers of 10 together. And remember, when you're multiplying exponents with the same base, you keep the base and you just add the exponents together. And then write your simplified answer. Now here's the last one that's kind of important. If the number then, if it makes it a number that's not between 1 and 10, then we have to move it so it is between 1 and 10. And that might change the exponent then. So I'll give you a couple examples. You can follow along. You can try them on your own if you want to pause it and try it on your own. But I'll show you how to do this. So first we're going to do they're already in parentheses. Step 1 is done. Step 2, multiply the constants together. So that would be 1 times 9.3. So I'm going to go 1 times 9.3. And that will be 9.3. Then it says multiply the powers of 10 together. So we keep the base, so the powers of 10. This will be 10 to the third, or negative third, times 10 to the negative fourth. Keep the base. Okay, what's going on here? So it's going to be 10. So we have 9.3 times 10, and then we add the exponents. So if it's negative 3 and negative 4, it's going to be negative 7. All right? And that's your answer. This is a number between 1 and 10. This has the power of 10 and an exponent. So that's how you multiply scientific notation. We're going to try one here. This one actually won't work out so nicely. I'll show you why. Whoops. So we're going to do the same steps. We're going to multiply the constants together. So let's do that 6 and that 9.91. I might have to pull up my calculator here. So I get 6 times 9.91 is going to be 59.46. So 6 times 9.91, I got 59.46. And then I'm going to multiply the powers of 10 together. So 10 to the third power times 10 to the first power is going to be, it's going to be 10 to the fourth power because you're just adding those together. So I get 59.46 times 10 to the fourth power. Now, the problem with this, though, is that this number is not between 1 and 10, and it needs to be between 1 and 10. So if we're going to take a bigger number and make it a smaller number, we have to move it 1 over. So we get 5.946, and then we actually add 1 to the exponent, times 10 to the fifth power. Because if you think about it, this was supposed to be moved 4 places over to get to your thing. Now since we moved it back 1, we're going to have to move it 5 places over to get to where it's supposed to be. So that's why we add 1 to that exponent. So that's where that last step comes in handy. If you need to put it into official scientific notation to make that a number between 1 and 10. All right, now we're going to do it with division. Not a whole lot different, actually, because we're going to rewrite the problem in the parentheses if it's not already. Step 2 would be divide the constants. So instead of multiplying the constants, now we're dividing the constants. And then we're dividing the powers of 10. So you may recall with dividing powers of 10, you keep the base, and you subtract the exponents. And write that simplified answer. And if need be, simplify it so that the constant is a number between 1 and 10. So here's our first example. 7.1 times 10 to the 6th divided by 8.2 times 10 to the first. So let's do this part first, and then we'll do this part. So 7.1 divided by 8.2. Looks like this is going to be a long decimal. I'm going to actually round it. Usually I wouldn't say round it, but it'll be 0.8. I think it was 8.6. We'll round it up to 8.7. All right, now times 8.6 or 10 to the 6th power divided by 10 to the first power. You keep the same base, and you do 6 minus 1, which is 5. So it's 0.87 times 10 to the 5th. Now, remember, this right here needs to be a number between 1 and 10, and it is not right now. So you have to move the decimal over 1 place to the right to make it 8.7. And then we're taking a smaller number and making it bigger. So we're going to put it, we're going to make this one less. So it'd be 10 to the 4th. So again, it's opposite of what you think of when you're going from scientific notation to standard notation. All right. Because since you moved it to the right one, you don't have to move it to the right anymore. So you can take one of those off. So it's 8.7 times 10 to the 4th. All right, one more example. Let's do this division first. 4.2 divided by 3. and then 10 to the fourth divided by 10 to the negative fourth. So 4.2 divided by 3. 4.2 divided by 3 is going to be 1.4. So we get 1.4 times, keep the base of 10. Remember, do the top minus the bottom, so it'll be 10 to the 4 minus negative 4. And when you have minus a negative, that becomes a plus. So 4 plus 4 would be the exponent of 8. And this works because this number is between 1 and 10, so we don't have to change it at all. So that's how you do dividing of scientific notation. You really just divide the constants and then divide the powers of 10, the exponents. Same thing with multiplying. You multiply the constants and you multiply the powers of 10. All right? So let's do one application problem before we're done here. It says a cylinder contains 3.01 times 10 to the 23rd hydrogen atoms. That's how much is in one of these cylinders. If the mass of one of those hydrogen atoms is 1.67 times 10 to the negative 27th, what is the mass of all the hydrogen in the cylinder? So we know there's this much hydrogen, and each hydrogen atom is this big. So think about it. If you have 25 rocks, and each rock is 2 pounds, you do 25 times 2. So that would be my hint for you. We're going to multiply it out. All right? So we're gonna multiply it out. It'll be 3.01 times 10 to the 23rd times 1.67 times 10 to the negative 27th. So our first step, I just wrote it in with parentheses form. So we're good to go with that. Next, we're going to multiply the constants together. So 3.01 times 1.67. I'm going to use my calculator for that. 3.01 times 1.67 equals 5.0267. 5.0267. What's awesome about that is that it is between 1 and 10. All right. Now we have to multiply the exponents together. We keep the base of 10 and we add the exponents. So 23, so this will be 10 to the 23rd plus negative 27 will get you a negative 4. So that's our exponent. And we have 5.02 times 5.0267 times 10 to the negative fourth. That doesn't actually say what the label would be, so we're going to just say units. All right, make sure you always have a label. If it doesn't give you a label, we're going to use units. All right, so that's our real-world connection, multiplying cylinders and multiplying and dividing scientific notation. Make sure if you have questions or certain ones you want to highlight to ask questions on, please do so. And otherwise, I hope you learned something about scientific notation today. And unfortunately, we didn't have any pi, but maybe next time. We'll see you later.